Okay, so today our topic is reciprocal lattice as we were continuing with the second unit of condensed matter physics, and in the first unit we learned about direct lattice crystal structure. Then we did the derivation for the interplanar distance, and also we did different types of lattice structures, which included 5 lattice structures in the 2 dimension and 13 lattice structure in the 3 dimension. What we did in the second unit was X-ray diffraction, and I'm pretty sure that you all have pretty well understood what is X-ray diffraction. When the light comes, it gets reflected from the crystal and we get diffraction pattern, and we have derived the relationship for the Lay's equation, and also then the diffraction X-ray diffraction, yeah, Bragg's diffraction law from the Lay's equation. I just want you to just imagine this thing, that just think you are listening to someone who is playing guitar. What will you feel? Will you feel each one string vibrating separately, or will you enjoy the rhythm of the music at a whole? Obviously, we enjoy that full music at a whole. But what happens is that whole music has arisen only when the guitar player is putting his or her finger on one string, then the second string, and the rhythm goes on. Similarly, this is how the diffraction happens in a crystal. In a crystal, the X-rays which is incident, it gets diffracted from the atoms. One atom is diffracting X-ray, then we are having another atom, because lattice or the crystal is having numerous atoms. So the X-ray is getting diffracted from different atoms, and what we are getting as a diffraction pattern is a constructive interference of all those diffracted X-rays or electron beams which are diffracted from individual atom. So what I mean to say, जो हमें बाहर दिखता है, that is something on a whole. It is not a single wave getting diffracted from one atom. It is the interference of numerous waves which are diffracted from different scattering points. So diffraction pattern को समझना, to understand the diffraction pattern, it is a bit tedious for us if we see the direct lattice. जो हमारे पास लैटिस है, अगर हम उसको देखेंगे तो हमें डिफ्रैक्शन पैटर्न को समझना बहुत मुश्किल हो जाएगा, बिकॉज हमें पता है कि ये जो हमें डिफ्रैक्शन पैटर्न मिल रहा है ये काफ़ी सारी वेव्स की इंटरफेरेंस से मिल रहा है, और वो वाली वेव्स कहाँ कहाँ से डिफ्रैक्ट हुई दैट वी डोंट नो. सो टू अंडरस्टैंड दैट, the scientists introduced the concept of reciprocal lattice that we are going to study today. The reciprocal lattice. Now this is what? This is a hypothetical lattice. अगर हम इसको ड्रॉ कर लें तो हमें डायरेक्ट लैटिस की ज़रूरत नहीं पड़ेगी अपने कैलकुलेशंस के लिए. Direct lattice is a bit complicated if we look towards the diffraction of wave. So this reciprocal lattice is the lattice which we need to study how the waves behave in a crystal. So what is the importance of reciprocal lattice that we have learned till now is कि हमें जो बाहर डिफ्रैक्शन पैटर्न मिला है वो कहाँ कहाँ से मिला है, इसको हम अगर डायरेक्ट लैटिस को देखें तो वहां से समझ नहीं आएगा. बट अगर हम रेसिप्रोकल लैटिस के ऊपर फोकस करें तो येस वी कैन इजीली अंडरस्टैंड दैट हाउ वी आर गेटिंग दिस. तो हमें डायरेक्ट लैटिस से ही ये रेसिप्रोकल लैटिस ड्रॉ करना होता है. सो वन थिंग दैट यू हैव टू कीप इन माइंड दैट द रेसिप्रोकल लैटिस इज नॉट अ रियल लैटिस, इट इज अ हाइपोथेटिकल लैटिस दैट वी आर जस्ट ड्रॉइंग फॉर आवर कन्वीनियंस. ओके, सो In this lecture, we will be studying how to construct this reciprocal lattice, then what is the meaning of the reciprocal lattice, and relation between reciprocal lattice and diffraction. How diffraction is dependent upon the reciprocal lattice, then the geometrical relationship between reciprocal lattice and original lattice, what we called as direct lattice. So this whole we are going to study in this lecture. So to start with, I would like to show you some of the example of real lattice and reciprocal lattice. So in this figure, if you see, this is the real lattice, and you can see that this is a rectangular lattice. In fact, A is not equal to B. So if we look towards the reciprocal lattice of it is like this. So the reciprocal lattice को हमने real lattice से ही draw करना है. तो अगर हम इसको देखें तो ये इसका 90 degree, if we rotate it, it looks like a 90 degree image of the real lattice. So this is a rectangular lattice, this is again a rectangular lattice. अभी दूसरी एग्जांपल दी है, ये एक लैटिस है और इसका रेसिप्रोकल लैटिस ये होगा. So what I mean to say is that the reciprocal lattice is drawn from the real lattice. और क्यों ड्रॉ की जाती है? बिकॉज जो एक्स रे का डिफ्रैक्शन है वो सारा हमें इसी से ही समझ आएगा. सो आई जस्ट वॉन्ट टू tell you the definition of reciprocal lattice. Reciprocal lattice is something fundamental to solid state physics because it greatly facilitates the description of periodic structure. It is used to describe X-ray diffraction from periodic structure. अभी मैंने बताया that reciprocal lattice is important because X-ray diffraction को study हम इसी से ही कर सकते हैं. So how to draw reciprocal lattice is the task of today. So I'm just taking a simple unit cell in a direct lattice. अभी direct lattice का मेरा मतलब है जो हमने अभी तक study की है. Fine. तो हमारा जो here we are having x axis, here we are having y axis, so like this. तो अभी simple एक unit cell है. When we'll repeat it, we will get a whole crystal structure or whole lattice. So let's draw. This is my primitive translation axis towards x-axis, which we call as A, and this is my primitive translation axis towards y-axis that we call as B. Agar I tell you to draw the different planes you are finding here, इस लैटिस में हमारे पास कौन कौन से प्लेन्स हैं, अगर हमने वो स्टडी करना हो तो व्हाट वी विल डू. एक तो मेरे पास प्लेन ये बन रहा है, इन दोनों प्लेन को मैं फैमिली ऑफ प्लेन कहूंगी बिकॉज दे आर पैरेलल टू ईच अदर. सेकेंडली मेरे पास जो प्लेन बन रहा है दैट इज दिस वन. सो दिस इज अनदर फैमिली ऑफ प्लेन. अभी मैं एक और ड्रॉ करूं तो I can get the plane, this one. Also I can draw another plane and that will be this one. So if I write, I have got first plane, second plane, third plane and fourth plane. Okay, so let me just erase it. So now I want you to choose one origin point and draw perpendicular to all these set of plane. तो पहला जो मेरा first plane है that is drawn by yellow light, yellow color. So let me choose this yellow color, almost yellow color, and इसके this set of plane के मैं परपेंडिकुलर ड्रॉ कर रही हूँ ओरिजिन से, सो आई एम श्योर यू कैन अंडरस्टैंड दैट दिस विल बी माई परपेंडिकुलर बिकॉज दिस इज परपेंडिकुलर टू द येलो लाइन. सो जो फर्स्ट सेट ऑफ प्लेन है उसके मैंने परपेंडिकुलर ड्रॉ कर लिए. सेकेंडली जो मेरा ब्लू प्लेन है, तो ब्लू प्लेन इज towards the y-axis, so I will draw perpendicular to the blue line by using this blue color, and the perpendicular to this blue line will be towards this, right? Then I want you to draw the perpendicular towards that pink. So pink color हम लेते हैं. I hope this will make a sense. So the pink perpendicular is, see, I'm making 90 degree here, 90 degree here. So fourth plane is the blue plane. So the blue color I'm choosing, and the plane will be having perpendicular towards this direction, making 90 degree here, 90 degree here, and I hope you all must have understood. So 4 planes, and what we have got is 4 planes and 4 perpendiculars. Also, if you remember, we have done Miller indices and we call it as H, K and L. Each family of plane are having their own H, K and L. That means if we talk about first, it will be having H1, K1, L1. If we talk about the family of plane which is denoted by 2, they will be having H2, K2, L2. Similarly, for the third set of plane, that is H3, K3, L3, same H4, K4 and L4. Also, in the first unit, we did how can we find D from these HKL. If I talk about the cubic structure, the formula was 1 divided by H square plus K square plus L square. So that means if we are knowing these H, K and L, we can find interplanar distance for each family of plane. So first step that we have done till now to draw a reciprocal lattice from a direct lattice is choose one origin point, draw normal or perpendicular to each set of plane that you have found in the lattice. That we have already done, हमने perpendicular draw कर लिया है. थर्ड स्टेप आता है D निकालो किनका, जो आपके डायरेक्ट लैटिस में फैमिली ऑफ प्लेन है उनका इंटरप्लेनर डिस्टेंस निकालो. सो दैट मीन्स वी हैव फाउंड D1, D2, D3, D4. Now on the perpendicular of the first plane, which was this yellow, I am marking a point at a distance. At what distance? At a distance 2 pi by D1. Why D1? Because I am talking about first family of plane. So the interplanar distance was D1. So I will take the point at a distance 2 pi by D1. Say it is here. Secondly, I will take 2 pi by D2 and so D2 is my this pink color. No, that is blue color. Okay. So 2 pi by D2 and that is here. Now you can easily find that why I have taken this D2 as smaller and this distance as larger, because here the D1 is in the denominator. You can see this is D1 and this is D2. D1 is less than D2, so in the denominator you will get that this distance will be higher and this distance will be lower. Okay. Next, we want to find this on the third set of plane, that is pink, and that will be 2 pi by d3. This is my d3. So you will get the point almost here. Sorry, here. Okay. Then what we want is for the fourth plane is the blue color. So we will get 2 pi by d4. d4 is this. So again the point will come somewhere like this. Okay, so what I have got is I have got a new set of points, and those set of points I'm just drawing is here, here, here. Here was the origin. I'm talking it as O, and there will be point somewhere like here also. See, we were having a crystal like this, and we have got the reciprocal crystal like this. This is what I have shown you in the figure also. Let me show you again. Here it is. Sorry. So here is the 1 unit cell that I have just drawn, and the reciprocal lattice is of this shape. So that means the 3 steps that we have to follow. First is draw perpendicular to all set of plane. Second is calculate D for all set of plane. And third is mark a point at a distance of 2 pi by D, and those points, those collection of points will give you reciprocal lattice. This reciprocal lattice is what we need in all of our future calculations, in our future lectures, in our future derivations. So that's it about reciprocal lattice. I hope you all must have understood. If there is any issue, you can ask me in the class when we'll meet physically. Thank you so much.